Okay, let's get started. We will first continue our previously unfinished exercise for lecture 5. So let's get the workbook called Power Query. If you haven't done so, please go to File under Canvas, lecture 5, and we were finishing the remove errors, and we will start with the transpose spreadsheet. For some reason, it's getting dark again here, so never mind. So let's take 30 seconds, 1 minute to go to this page. So in the previous lecture, we spent some time talking about this. You can think of this as a separate software, separate user interface called Power Query Editor in Excel. And we did a few simple exercises to briefly showcase you what kind of things it can do. Roughly speaking, it will help us do data import, data pre-processing, data transformation, data cleaning, and related stuff. So we talk about things like split columns, remove duplicates, remove errors. And the next exercise, there are like 4 to 5 more exercises that we are going to do today before we go to the next lecture. And some of them are slightly more complicated. So if you have any questions, don't hesitate to interrupt me. So we will start with this transpose. So in mathematics, the word transpose, whenever you have a matrix, you have the columns and rows. The operation of transpose means that you flip the matrix across the diagonal. So the columns will become rows and the rows will become columns. In this example, we have a very cute small data set where different rows are different products, A, B, C, and D in that order. And different columns are different months, January to April. So the operation of transpose is similar to when we talk about data visualization, right? It was similar to a row and column-wise interpretation. Instead of putting products as rows and months as columns, you want to transform the data set so that it looks something like this. And same as usual, you can do something like this. We are not going to spend more time in details. In basic Excel, we can do this by copy the table and paste as a transpose. You can try it out. But what we will do instead, we will use, once again, we will use the Power Query Editor to do two different things. One is transpose. Another thing is reverse. So reverse is simpler and more straightforward. Originally, the order of displaying the rows are in the order of product A, B, C, and D. So if we want to display in the reverse order, D, C, B, and A, well, if your data set was originally sorted according to certain criteria, then it's easy. You just choose, if it's alphabetically aligned for the product name, you simply use the reverse alphabetical. But if the original data is in a random order or in order that does not using any sorting criteria, then reverse is not straightforward, right? Later we will show that by using the Power Query Editor, we can do either transpose or reverse by a few simple clicks. So in case you have already forgotten, the most important step is to import existing data set. Here we have an Excel table into the Power Query Editor. So you can either double right click to get data from table or range, or you go to data and same thing there. So get data from table or range. If it's the first time you open this query editor, it will take some time. And sometimes it will also crash. So remember to save your Excel file frequently. So after loading the data set, right, we have a table here. And the rows are the products and the columns are the month. Right, any questions in this step? The functionalities we are looking for is under the menu called transform and towards the left side. So we are going to do the transpose and reverse. So let's first show the simpler one, which is reverse. If we want to reverse the row of display so that row 1, 2, 3, 4 will become 4, 3, 2, 1, a simple click will do it. Instead of A, B, C, D, we can display in the reverse order. So this will be the most useful, let me repeat, when your original data set does not follow a specific sorting criteria in any of the columns. So the original order, you just want the reverse. In basic Excel, it's not clear how we should do that. But using the Power Query Editor, we can simply, by using a single click, to do this. As we mentioned in the previous lecture, if you want to cancel your previously done operations, you simply go to Apply Steps And so our most recent step was to reverse the rows. If we don't want it anymore, we can remove it. So that was the reverse rows. For transpose, it's a little bit trickier because if we directly click on transpose, we realize, okay, we are losing certain information. Specifically, the first column, which are the product names, product A, B, and C, and D, will become the first row. However, the original column names, January, February, March, April, has been lost. So it was removed. Because those column names was not originally the part of the table, they are considered the labels or column names instead of the column table content. So it has been removed. So how we should do that, there are certain little tricks. So let's cancel the previously done step. So what we are going to do is, instead of treating the column names, January, February, March, April, as the column names, we will use them as the first row. So we will leave the column names empty and shift them downward as the first row. To do this, we will simply click. Instead of using first row as headers, we are doing the other way around. We are using the headers as the first row. And later you will see why we do this. So in the drop-down list here, just next to the transpose, we will use headers as first row. So by doing this, we no longer have any column names, but the previously column names have been included into the table content. So when we do the transpose now, we no longer lose the previously column names, January, February. So we can now do the transpose by a single click. And now we have successfully maintained all the column names as the row names. Well, we're not done yet. We're not done yet because you may argue, oh, now I have the first row to be the previously row name, now the column name. I want them to go back again and become the column name. What should we do? Well, this is also straightforward. We will just reverse what we have done, right? We will just click use first row as headers. So our current first row, instead of the table content, we want them to shift up to become the new column names. Instead of appearing in the first row, we want product A, B, C, D to appear as the column name. So we will just do a simple click of first row as headers. So there are certain little tricks, but using a few steps, we have transposed the table successfully. And if this is a table that we like, we can, same as before, we can choose close and load and print out the existing transposed version of the table in a new spreadsheet. Again, let me repeat, this is very important because one special feature about this Power Query editor is that whatever transformation, whatever pre-process you perform on the queries inside the editor, once you load it out, it will not automatically change the original dataset. So the original dataset was untouched. But now the output version is the transposed version. Right. Of course, if you are a bit confused about, use first row as headers and first rows, well, you can manually, just after transposing the content, you can manually load it first and manually remove the first unnamed row. That's also viable. As long as you get something like this, which is what you want as the transposed table, then we're good. That's about this exercise. Then we will continue to talk about 3 to 4 other, arguably more useful features that we can do using the query editor. The next one is called unpivot. From the name, you can imagine there are certain connections with the pivot table or the word pivot, which means rotate, right? So it's a bit hard to explain. So I'm going to use a screenshot, and later I was also checking with Copilot, what do we mean by this unpivot operation? So imagine, let's take a closer look at this dataset, which is quite wide, not long, but wide, which means we have a lot of columns. So each row is a product category. We have clothes, tools, and so on. Each column are different months. We have all the way from January to December, so we have 12 different columns. Well, you can argue that recall that back in lecture 1, I was telling you the standard data format, we would hope that each row is an individual observation. Each column is an individual feature. Well, looking at this data set, you can argue that this is more or less standard. Well, each column are separate month, so they are different. They are different features. But you can also argue that potentially they all represent, although different month of sales data, they all represent sales data. So there might be a way to transform the data set so that it will look something like this. More generally speaking, whenever you have a data set that different rows, it doesn't matter, but for different columns, they are consistent, they represent similar type of output. Then what we can potentially do is to put a very wide table, compress them to make them longer. How exactly we're going to do this? We are going to put all the different columns, in this example, all the different months, under the same single individual column called month. Here is, in this example, is store. So you can imagine here we have 4 product categories. We have 12 months. So in total, we would have 4 multiplied by 48 numbers. Our objective is to put the product category in a single column as the first column, put all the month in the second column. So for all the possible combinations, all the 48 numbers, we put in the third column. So this is what we call by unpivot. So if I'm explaining not clearly enough, let's take a quick look at what is the large model. It will give a mostly similar, almost the same example. Transforming columns into rows to normalize your data structure. Right. So we will try to do this in Power Query Editor first, and after we unpivot the data set, hopefully you see both are acceptable formats. It depends on which one is more convenient for you to work with. Right. So the intuition, if you want to remember this concept, just remember whenever you have a wide data set, and for the multiple columns, they are similar so that you can potentially combine and compress them into a single column of values. Then you can do something like this, something called unpivot. So let's try to do this and see the output, what the output will look like. And hopefully it will make you understand better. Same as before, the first step is always to load the data set, the Excel table into the editor. So right click, get data. And the functionality we are looking for is, again, under transform, in the middle area, there's a button called unpivot columns. But here, we first need to select which are the columns that we want to unpivot. By definition, we want to unpivot all the columns that are existing different columns, but they are of the same type. In this case, we want to select all the columns that represent month, which means in this data set, all the way from January to December. So we are going to select all the 12 columns, which is all the columns other than the first product column. We can use the short key. Of course, manually selecting the 12 individual columns are not very, convenient. Remember the short key on Windows or in Excel to select the first item all the way to the last item is the shift key, right? So we select January, which is the first month. Then we go to the last month, we press shift and select. By doing that, we have selected all the month columns, and we just by a single click of unpivot columns. Try to understand what is this operation is doing, right? Again, in the current data format, they share a consistent data values, but in different columns. What we want to do is to compress them into a single value column. So let's try. Right? If you compare before and after, instead of having so many columns, we are having so many rows. Why? Because for each product category, we have 4 of them, and each month, for all the possible combinations, we have a corresponding sales value. So we should have a total of 48 rows now. But we have successfully reduced the number of columns. And one can argue that this current data format is easier to work with because imagine if you have other columns, which is not month, then now they can be put into somewhere else. Right? Now you can argue the data becomes slightly more compact. So after the conversion, you can manually, because by default it will show in this column. Excel does not know what does it mean, right? After you unpivot. But we know they represent month, so you can manually change the column name to be like month. So this is only one way of doing it. Let me quickly show you another way, which is exactly the same, equivalent, but maybe even easier. So to do this, let's redo the exercise by canceling what we have done. So go to the applied steps, cancel, revert the previously done operations. Well, instead of manually selecting all the columns other than the first one, we can do something like we only select the first one, and instead of unpivot the current column, we can, in the drop-down list, choose to unpivot other columns. If you think about this, this is exactly the same. We have in total of 13 columns. Previously, we select column 2 to 13 and unpivot those columns. This will be equivalent if we select column number 1 and unpivot the other columns, which essentially will do the same job. So we select the product column. So this is simpler because you do not have to manually select multiple columns, right? Unpivot other columns, which will give us exactly the same output because they're doing the same thing. And same as before, we can manually change the column name to be more informative. Right. And once we are done, we can close and load. If you click here, by default, close and load, it will automatically print out your resulting table into a new worksheet. If you want to manually choose whether to print it out or manually choose where it's loaded or printed, you can, in the drop-down list, choose close and load too. If you do not want to print it out anymore, you can choose only create connection. The result table will not be displayed at all. So you will end up, so you still, in the Power Query editor, you still have the completed version. Oh, that was the transpose. No wonder I was confused. So for this unpivot, you still have the updated version. If you double click, you still have the updated version after our transformation, but it's not being printed out anywhere in the workbook. So instead of, as compared to the previous transpose table, which was loaded, now you have a connection only. If you regret your decision, you feel like, okay, I want to print out my table again, you can, under the queries and connections window, you can right click on the connection and choose to load it to somewhere again, like into a new worksheet. I will repeat on this because every year in the final exam, I had questions asking, oh, my table is lost, I cannot print out, I cannot load it anywhere. Well, that's understandable because I would argue that this is one of the bad designs by the Power Query editor, so it's probably not our fault. So then the next exercise is grouping for summary, which, telling by the name, you can probably imagine it will do a task that is very, very similar to what we have just learned in the pivot table. So let's take a look at this slightly bigger data set. It's a sales data set containing the information like order numbers, order date, and order amount, which is the last column called bill. Now, let me ask you, or let me ask us, I want to summarize this data set by computing the summation of the sales or the bills by customer's promise. So whenever I ask a question like this, the most straightforward or intuitive way might be using a pivot table, which I hope you already know how to do. Right. So let's quickly do it in pivot table. Then later I will show you it's equally easily to do it in maybe less interactive, but also very simple in the query editor. So hopefully you still remember. Because this is already an Excel table, we go to the contextual tab, table design, and summarize with a pivot table to insert an empty pivot table. We can choose to put in a new worksheet because the data set here is already pretty large. And let me repeat the values I want to compute. It's the summation of the bills by province. So we will drag bill under values to compute the summation of the bill. And we will use either row or column. It's up to our decision. So let's use row. And we will drag province, customer province, under rows. So by two simple drags, we now know the summation of the bills grouped by customer province. Right? We have all the groups here. In this case, they are all provinces. And of course, if I further ask you more details, if I want you to group by province, then within each province, I want you to group by another feature, for example, by, let's see, by order date. You can drag another order date under the customer province. Let me put it bigger. And the pivot table will be arranged in row, first by province, then within each province by the order date. And it will show the summation of the bills by the order date, by province, within province. So this is typically what we do using a pivot table, which I go pretty fast because we already covered this. We can do something similar in the Power Query editor. So let's load this data set into the editor first, right click, get data from table arrange. The functionality we are going to select is this big icon under home in the middle area called group by. It will do exactly the same thing, which is according to certain column, certain feature, it will group the corresponding observations and compute summary statistics we want. It can be summation, it can be average, it can be any other things. So let's just click group by. So there are two versions. One is basic. We will start with the basic one. Essentially, it represents that we only have a single grouping criteria. In this case, the only grouping criteria we will be using at first, it's customer province. Right? So let's, in the drop-down list, let's find customer province. And then we get to decide, similar to a pivot table, right? We get to decide what kind of summary statistics we want. Here, we just, in the drop-down list, we find sum, and we can decide it's the summation of the bill. Same. And we can manually change the new column name, which is after we compute the summation of the bill, how do we want to call it? Depending on what you like, here I will just call it sum of bills. And we can click OK. The output, if you don't believe it, you can compare quickly with the pivot table. It should generate the same output. It's the summation of bills categorized or grouped by the customer province. So this is just to quickly give you an alternative in case that you prefer using the editor over the pivot table. So let's revert what we have done. And let me quickly also show you what we mean by the advanced group by. Well, the only different thing, more or less the same, the only different thing is that the advanced group by will allow us to use multiple grouping criteria. So previously we were using this customer province, but now we are allowed to add in another or even more grouping criteria. So within each province, we were using the order date. So we can also do that, order date. Then we can do the same, and here potentially more. In the pivot table, we also allowed to use multiple summary statistics. In the previous exercise, in the previous lecture, we were computing summation and the count at the same time. But here, let me quickly just only by again showing you the summation of bill, so that our output should be the same with what we have in the pivot table. Sum of bills. You can potentially add more, but here let's just show one. So this list will be long because for all the different province order date combination, it will show you the sum of bills. Right? Just an example. And here, by using this example, let me also show you if you do not, after doing some operations, doing some cleaning, if you do not like what you do, you want to cancel it, forget about it. You can simply click on close the window. It will ask, do you want to keep the changes? If you want to forget about everything you have done, you can discard the changes, so nothing will happen. So this table is not even not being loaded into the query editor if you check. Right, not there. So this is about the grouping exercise. Then in the last 3 different spreadsheets, we are going to talk about 2 similar but potentially more challenging operations. One is called append, the other is called merge. So I was also trying to explain it better by checking with the Copilot, because personally I often get confused. One is called append, the other is called merge. Both involve certain operations that we deal with multiple data sets and we want to combine their information. So to answer the question of their difference in a simple way, append will be combining the tables by rows, and merge will combining the tables by matching the records and adding in columns. Right? So it will again give us some examples, but it's not useful because we will be using our own example. So let me repeat the difference, just make this clear. Append, I will argue that append is much easier when combining 2 data sets, because it's like when you have 2 tables, you are combining them vertically. By vertically, we mean add more rows. To do this, they will have to share as many as possible the same columns. And after completing the exercise, I will show you what are the requirements of appending 2 data sets. While merge, we will later see, is much more challenging, because doing a merge is as if combining multiple tables horizontally. We want to add in new columns by looking up information from other tables. So let's start with this append exercise. Let's take a look at these 2 data sets. And let's try to combine or append them in the Power Query editor. So the two data sets are about the order information, same as before, but they have different number of columns. The first table, I already give it a name. I call it append 1. It contains order information of order number, customer name, and sales. Same for the second table, but the second table also called append 2. It has one extra column telling us about the customer province. So the first thing and the most important thing we need to make sure when appending two tables is that if we want to append combine or append the corresponding columns, we need to make sure their column names must be the same. For example, here, we are certain that the order numbers should be connected like in this way. So we need to make sure here we use order number and here we also use the same name, exactly the same name, order number. Because Excel will use this column name or column label as the identifier to decide, which columns it should be combined, not the position. Later we will see, okay, even if the order of the columns can be potentially different, the names must be the same. So we will try to complete this exercise in the query editor. But before that, let's talk about another challenge, a new challenge we have never been faced before. So far, for all the exercise dealing with the Power Query editor, we have only done one type, which is to load a single table into the query editor. But here, this is the first time that we may need to load more than one. We need to load both tables into the query editor, which turns out to be quite challenging. So if you want to stick, let's try to do this using our old way. So we go to the first table, we right-click, we get data, and we have successfully loaded this append 1. Well, naturally, when I first used this as well, I would try to go back to Excel and try to load the second table, right? Well, surprisingly or frustratingly, it's the special feature that whenever we are using or opening the Power Query editor, the basic Excel is no longer responding. It's not crashing, it's just not responding to any of our actions. So that's quite bad. I would argue, again, this is one of the bad designs. So there are multiple ways of doing this to load in a second table. So first, and the most intuitive way, of course, you can close and load this current table and go back to the basic Excel and load the second table. Well, that's one way to do it. And so let's just try this way first. And depending on whether you want the first table to be printed out, you can choose either to directly load it and print out the first table as it is in a new worksheet, or alternatively, you can choose to only build a connection like this. Either way is fine because you can always convert it back. So depending on which way you prefer. Here, let's try create connection only. So now append 1 is only a connection. It will not show up anywhere in the workbook. And then, okay, fortunately, our basic Excel is working again, so we can load our second table. Right, by doing this. But of course, later after our append, so let's first do the exercise and see the challenge of when you have only a connection, your table will not be printed out, right? So later I will show you again. When you only have a connection, you need to load it again to print it out. So let's quickly complete this append exercise, which is the easy part. So we will go to I think it's under home, under combine. There are two different icons. One is called merge, the other is called append. Sometimes I get confused by which is merge, which is append, but I think the icons are designed in a pretty good way. Because if you see the append icon, okay, we are combining two data sets vertically by joining their rows. Right. So here we know we should use append. Well, the remaining should be most straightforward. We are now in append 1. So we select the second table to append, which is, of course, append 2. And by doing this, Excel, during the append operation, Excel will use the column names as the identifier. So let me repeat, it's very important that you make sure the columns that you want them to belong the same should have the same name. It cannot be different. Otherwise, it will be appended after the append. They will be in different columns. And for the columns that one data set has, but the other data set does not have, you will have empty observations, which will be fine. because we do not have that information anyway. So here we are done. We are done with the appending. And right, if we want to print out this table, that was the challenge I was talking about. You can choose close and load or directly close and, well, let's choose close and load. It will, because we previously load the second table, so here it will print out the second table. But the first table, because previously when we close the editor, we choose not to print it. So the first table is not anywhere. We cannot find it anywhere in the workbook, right? Append 1, where it is. Because now it's a connection only. So after we append the two tables, the result table is nowhere to be found. So how exactly we can print it out again? Exactly. So this is why I repeat. So because potentially this can be confusing. Because currently this table is connection only means that we are not printing it out. If we regret, we should print it out, right? If we want to print it out again, we will go to the queries and connections, find the updated table, which is append 1, right click to load it. Instead of only create the connection, we regret our decision and we print the table out again, maybe in a new worksheet. So right now we have our appended version of the table. So this exercise itself, appending the append operation, is relatively straightforward. But I want to use this example to show you our first way or the first approach of loading multiple data Excel tables, which is a bit tedious. You need to close the editor before you load the second one. Well, let me delete. If you do not like any of the current queries, you can right click on it and choose to delete them. If you delete it, it will no longer show in the Power Query editor. So I will delete both append, and I will show you the second way, a different way of loading multiple tables in the Power Query editor. So let me quickly do this. So let me delete. So after you delete, well, interestingly, the printout table is still there, but the query or the connection or the data set in the query editor will be gone. So if you want, you can also delete those two spreadsheets. Well, I'll just leave it there. So the second way to import multiple tables, suppose you need to import 10 different data sets into a Power Query editor. By doing what we have done, you need to open and close the query editor 10 times, which is arguably very annoying. So an alternative way is that if you can double click on any of the existing queries, or alternatively under get data, you can manually open the Power Query editor. You can load the data, the Excel table from the Power Query editor, potentially multiple of them. So we open the Power Query editor, but this approach is also a little bit counterintuitive because the way that we load a new or multiple new Excel table is to find, let's go to new source towards the right, is to find the current file. Under new source file, we are going to look for our current Excel workbook. Again, I would argue this is not a very good design because we are already in the existing workbook, but we need to find the existing workbook, the current workbook again. For me, it's the current workbook is under downloads, is just Power Query, right? But you might have it in a different folder. So we will choose Power Query, and it will try to open the same workbook by detecting what are all the Excel tables in that workbook. So our objective was to load append 1 and append 2, so multiple tables. So we tick on the select multiple items and choose both the append. Right. So this is an alternative way of loading multiple Excel tables into the Power Query editor. And from there, you can perform this append operations again. We're not going to do this. And when you close and load, it will print out all the individual Excel tables, right? Append 1, 2, append 2, 2, right? So it's a bit tricky to manage all of them. Questions so far? Yes. Yeah, yes, that's what I'm going to. Very, 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 very nice question. So here are some of the insights or requirements. very good observation. So you pretty much cover all the things that we need to notice. They should share the same name. That's very important. And because this requirement is very explicit, Excel will use the names instead of their locations, column 1, 2, 3, as the identifier. So potentially, if you shuffle the order, we are not going to explicitly try this. For example, if the order number appears after the customer name here, we are still able to append them. So that is one convenient way. Order of columns can be different. And in case that it's the same column, but you use different name after appending, you can also try it on your own. They will be treated as if they are different columns. So column names is the only thing that the query editor will be using to combine them. Very good, very good. So then let's talk about the most complicated exercise, arguably in Excel. So it's a merge exercise. But before thinking about how to do merge, let's first try to understand why we need to do it. So in this exercise, first, merging by nature is more complicated because it's dealing with combining data sets horizontally by adding in new columns. For another reason that this exercise will involve, instead of a single table, like 2 different tables, 3 different ones. So let's take a quick look at why this exercise can be challenging. So we have 3 data sets. We have 3 Excel tables. I already give them names. And actually, to make our life easier, I already loaded them into the query editors, but only as connections. They are called order table, province table, and discount table. Let's see. Same as before, each table, the first order table is order information, which include order numbers, customer names, customer ID, customer province, product category, and the sales. So for example, in our first observation for this customer, he or she is from the Gansu province, and the product category for that order is bicycle. Our objective in this exercise is try to determine for each order what will be the discount value. To do that, we will need to rely on inputs from another table, which is the third table called discount table. So let's see. It turns out that in order to decide on the discount value, whether it's 70%, 60%, and so on, we need to use 2 pieces of information. For the combination of region and product category, we are going to decide on the discount value. For example, if the region is East and product category is bicycle, then we know that order should have the discount of 0.7. So, but the only question we have now, for example, let's go back to the order table and try to decide the discount value for our first customer. We know the province, which is Gansu. We know the product category, bicycle. Only using the province and the product category, we do not know what is the discount. So the missing information is the region. So to do that, we need to use the help from the second table, which is called the region table. Not the region, province table. So for each province, we need to map or look up which region, east, west, north, south, which region they belong to. So the looking up process should be something like this. For any specific order, for example, in the first order, we know the province is Gansu, but we don't know the region. So we go to the second table, we check the region of Gansu, which should be west. So once we know it's west, we combine the product category, which is west bicycle, and we check the discount value in the third table. West bicycle, which will give us a discount value of 0.9. So if you think about this whole exercise sounds very like a lookup exercise. So if you're interested, you can actually do this using lookup functions. But what I'm going to show you is by merging the tables, potentially adding in actual columns here. For example, here, in the first order table, I'm going to insert 2 new columns. One is the corresponding region information, and the other is corresponding discount information. Because our ultimate goal is to determine for each order what are their discount values. To do that, we're going to perform this task in 2 steps. First, we will merge. Let me delete this. First, we will merge the first and the second table to look up the region information for each order. And then, after knowing the region information, we will use both the region and the product information to look up the discount value. So there are 2 merging steps. 3 tables, 2 merging steps. And in the end, we are going to update the first table in terms of the region column and the discount column. Right? So because I already loaded the 3 tables into the Power Query editor, we can double click, but they are connection only, so now I'm not printing them out. So you can double click on any of those to go to the Power Query editor and start working on the merging exercise. So the first three. Right? So let's do this. Let's do this. So merging, as you can see from the icon, is not combining data sets vertically. Instead, it's trying to use certain columns as identifier to do the lookups. So potentially you can have more information as potentially new columns. So let me repeat, we are going to do two separate steps. First, we will merge order table with province table. Because in the current order table, we only know the province, but for each province, we do not know their regions. So we want to check for the regions by looking up in the, or by merge in the second table. And after knowing the regions, we use the combination of product category and regions and look up in the third table to determine on the discount. So let's do this. So we will go to the order table because eventually we are going to decide on the discount values for each order. So we are only going to update based on the order table. And we go to merge. So of course, the first table, when merging, there's a table 1 and table 2. Table 1, of course, is our order table. And table 2, let's first choose the province table to look up for the regions. Now the difference or the more complicated step is to determine, well, if you compare the merge and append, in append, Excel will, based on the same names, to automatically determine which rows to append. But here, we need to manually indicate what is the column of information that we should do the lookup. Naturally speaking, if you want to look up information in the second table, which column are we using as the lookup column if you think about VLOOKUP operations, right? It should be the province. Specifically, for each order, for example, Gansu, we check, okay, under the column province, which row is Gansu, we return the region. So we need to manually choose the corresponding province column. Here, pay attention, potentially they can have different names. Here is called customer province, but here is called province. It's okay, because we manually select the corresponding columns so that we force the editor to match using the two columns, as long as they contain the same information that we can use to do the lookup. After selecting the columns, well, on the bottom of the window, the editor will hint you, or it will tell you, how many of the observations have been matched. So here we are quite confident, we are quite happy. All the 15 orders can find a match. So we click OK. But we are not done yet. We are not done yet. After merging, so by merging, we are essentially combining all the information from both tables horizontally by adding in new columns. The only remaining decision is we haven't done is that we haven't specified which columns should we keep and which to throw away. So now, after sales, we have an extra column in the order table called province table, where it contains all the information from the second table. Let's click on this expand icon here. So here. Then there's a drop-down list for us to select what information we want to keep. Exactly, yes. Here we only need the region information because in the original table 1, the order table, we already have the province. So if you want to keep both, the province, let's try keeping both. If you want to keep both, the province column will be redundant. It should be exactly the same, right? So as a result, there's no need to keep all the information from the second table. So we can revert this step and by only choosing to keep region information. So by this merging and expand step, we have successfully added a new column of region information for each order. And now we are ready to merge it again with the third table, because previously we do not know the region, so we cannot know the discounts. Now we know both the product and product category and the region. For each combination of product category and region, we will look up in the final discount table for the discount column. So we are going to build in another column by merging to decide for each order what will be their corresponding discounts. So we will continue on the order table, and once again we will do merge. The first table is order table. The second one is the discount table. So this step is even trickier, because instead of a single column as the identifier or as the lookup column, we need to rely on both columns. So for example, if you only know the region to be East, but without knowing the product category, the discount can potentially be different. If you only know the East is the region, the discount can be 0.7, 0.6. You will have to combine both pieces of information of region plus the product. East bicycle, East clothes, they're different. So we need to select manually multiple, in this case it's 2 different columns, to do the matching. And one thing to pay attention to is that we will have to select them in the correct order. So let's see. We will select region first, then product category after that. So same as before, we click on region. And then, you still remember the short key. When selecting multiple items, here's multiple columns, we use the short key of control. So press the control key and we will select the product category. If you have done this correctly, you will see a little index of 1 in the region and index of 2 in the product. If you want to do the reverse way, that's also fine, but you need to make sure the order must be the same in your selection of the other table. We will do the same. We will do the same for the second table, which is select the region as 1 and press control, select product as 2. So column 1 will match column 1, region will match region, and product will match product. We allow the column names to be different, but we need to select them in the correct order to let the editor know. And the same as before, we left this the other options by default. We will later use the last exercise to briefly talk about what do we mean by this. So we have all 15 records matched. And here we click OK. Then we have all the information from the third table, which is the discount table. And the last step is to choose which are the values to keep. And of course, discount is the only value that we care about, so we only choose to keep discount. So let's do a quick check, a sanity check. So for Anhui province, and the region is East, let's go to the discount table, see if it is indeed 0.7. So East, I didn't see the product tool. So East and tool should give us 0.7, right? East and tool, 0.7. So this is what this merging is doing. Essentially doing lookups by integrating more columns. And now we have finished the exercise. If you want to directly print out this order table as the result, well, you will be frustrated to see that this close and load to button is gray. We cannot click it. Again, this is due to the bad design. So the only thing we can do, well, you can keep the changes because this order table right now is connection only. It's not being printed out, although we have updated using 2 merges to update the table inside this query editor. But if you want to get it printed out in the workbook, we will have to go to queries and connections and manually load it by changing the create connection only back to load the table, maybe in a new worksheet. So by doing this, we successfully get the order table, which has the 2 extra columns of the region as well as the final discount value. So this whole process is a little bit tricky. Well, you may argue that maybe using a lookup function, you can do this faster. But when you are dealing with very large tables, maybe using the query editor will give you certain edges. Just give you another option. Questions at this point? So there are two things I want to highlight, the most challenging part. One is during the merge, you need to manually select. If you have multiple columns to be the merging matching criteria, you need to use the control key to select multiple of them in the same order. That's the first challenge. And the second challenge has nothing to do with merging. The second challenge is that for queries, if you have already certain queries that are only connections, maybe you cannot find it anywhere because they are only connections. You will need to load it again for them to be printed out. That is something a little bit less intuitive. So it's worth highlighting here. So now we're pretty much done with all the queries analysis. We will use the last cute example just to showcase. In merging, there are certain options that we did not even change. By default, we are using left outer join. What does it mean? If we try out different options, potentially what can be different? So this exercise is very good at showing you the differences. So I believe many of you have learned set theories in your maybe college or high school. At least you should have learned something called a Venn diagram. So in other words, you should be more or less familiar what is, for two sets that have certain overlaps, what is a union, what is an intersection, what are the set differences. If you don't get it, well, that's fine. I'm not teaching math here. But I'm going to use this exercise to show you, to give you a better understanding of the differences. So we have two very, very cute small data sets. One is for the five invited customers to, you can either think of this as a dinner or as a party. So our party has invited 5 people, A, B, C, D, E. Well, unfortunately, only 2 of them show up. So for the invited customer, only 2 show up, D and E. And interestingly, we have another 2 guests, F and G. They are not invited, but they attended. So we have 2 sets, the invited set and the attended set. And the intersection has only 2 people. So if we want to do something like a merge by combining the information, because for the invited customer, we have the invited date, for the attended customer, we have the attended date. If you want to combine the information from both the tables, then, well, then we should decide which are the customers, whether it's invited, attended, intersection, union. Which group do we want to keep in the resulting data set? So that would be the difference. Same as before, let's try to load both data tables, Excel table into the query editor. Again, this is a bit challenging because these are 2 different tables. So I'm going to use the dumb way or the straightforward way to load the first one. Well, invited. After loading, I'm going to close by only create the connection, and then I quickly load the second one. So we now have both tables ready. One is called invited, the other is called attended. So let's try merging the 2 tables. Again, we will click on merge, and one is invited, we choose the other one, which is attended. So here we will try out different options of how exactly we do the merge. This is called join kind. Again, think about a diagram, a Venn diagram. Left outer, from the name, you can probably guess. Here we have 2 tables. You can call it left table and right table. So the operation left outer will keep all the observations from the left table. In other words, we should see A, B, C, D. So let's keep it default to the left outer. And of course, we need to specify the names as the matching column, the matching criteria. And you can see the hint. Matches 2 of the 5 rows because we can only find D, E information in the second table. So if we click OK, still it will keep the information of A, B, C, D, E, but for D and E, only their information can be found in the attended information. So here we need to choose what are the, if we want to only keep the attended date, this will be what we have, what we get. I'm a little bit curious, and I don't know why. After I select expanding, the order will be slightly different. Instead of A, B, C, D, E, it will be A, D, B, E, C. Actually, I don't know why, but let's do not worry about this. So this is the left join. From the name, you can guess we are mainly focusing on the left table, which is the first table. That's why we end up with the same names or the invited customer only. So let me cancel the steps and redo this exercise by trying out some other different options. Again, let's choose attended and select the names. Instead of left outer, let's try right outer, which is symmetric if you think about it. Table 1 is the left table, right outer is the second table, so the right table. So instead, it should keep D, E, F, G if we expand the names. So we can try. Here is only D and E, but if you expand and include the names as well, it should only include, have a primary focus on the right table or the second table. Just to showcase what are the differences between the different options. I would personally argue that in practice, we rarely use right join because left join table 1 and table 2 is equivalent because it's symmetric as if we are doing right join table 2, table 1. Right? So you can always swap the positions of doing the join. So these 2 are kind of similar. So let's try some other options like full outer. By full outer, you can think of this, from the word full, it's something like a union, which means that we are including as many observations as possible. So in the output table, potentially you should have all the people in either tables. So this is somewhat like an OR argument we teach before. So we choose full outer, specify the name column. And here, by expanding, we can choose to include both the name and attend date because the second information in the second table should be expanded. So in the fully expanded table, we should have all the names, like all the possible people, whether it's invited, attended. One thing that you may not like is that all the names does not fully belong to the same column. Ideally, we want the names to appear in only the first column. Here, instead of empty, we want to put F and G there. Well, it turns out that you can use some other operations to clean this, like an if function. We're not going into details for that, but so this is the full join, which will include all possible informations from both tables. Then after talking about union, we have intersections, which is the other way around. So let's quickly try the last option, which is the inner join. By the word inner, you know we are doing something like an AND. We only keep the intersections, which are the observations that belong to both datasets. So let's choose inner join and indicating the column name. And this is what we have. So the good thing about inner join is that because we know that all the observations show up in both of the datasets, so there will not be any empty cells because for D and E, we know for sure that, okay, they have both the invited date and the attended date. But of course, the trade-off is that we will have far less observations because all the other observations, they have been ignored or removed. So those are quickly illustrate the differences between the different, join options. There are certain other options. We are not going to explicitly try it out, but here there are last two. The word is anti, left anti and right anti. You can think of those operations as if you are doing set differences. For example, if you try, you can try it on your own if you're interested. Left anti actually means that the observations that only appears in the first table. So instead of only showing D and E, it will only show A, B, and C. So we do not use that very often, but sometimes. So depending on what you need, three most commonly used are left outer join, inner, and full. Depending on whether you want to include the first table's observation or the union or the intersection. So that will be this merging exercise. Again, if you do not, because we didn't change anything, you can discard. So they never appear in the queries and connections. Well, it appears here because we didn't save for the invited. We didn't save. We have for the invited, we saved it before, but for the attended, we discard the changes. So these are more or less the exercise about the Power Query Editor. We didn't have time to go through some other exercises, which there are certain other functionalities which the Power Query Editor may allow you to complete or conduct them in a more convenient way. But if you're interested, again, you can try it out. And if you encounter any questions, feel free to discuss with me offline. So that's more or less it. Let's have a 15 minutes break. Come back around 30, and we will use the second half to do spreadsheet modeling. So we will use probably this, I guess, if I remember correctly, the last lecture for Excel for spreadsheet modeling, which involves certain mathematical modeling. But before that, I have to make several disclaimers. I know some of you are, especially from the DAO apartment, taking another course, and previous years, in previous years' course content, those lectures of spreadsheet modeling happens to be the same, and this is something that we try to avoid. So this year, we completely revamping this case using a different case, and arguably more relevant, and you should pay more attention to this because we developed this year's case simply from the previous year's final exam. So, but the disclaimer or the argument I was trying to make is that if you find this case too challenging, don't panic. This is not exactly the same exam question in the previous year. We made it because we are trying to make the comprehensive case for the course. Well, the current version is much more complicated than the original question appearing in the previous year's exam. So don't panic. And specifically, we are going to use a case study to learn spreadsheet modeling. I think it's this year. The other course was taught by Jeff, I guess. So we are trying to, using a different case. But I mean, the things we are going to learn are more or less similar. But our case, because again, it's developed from the previous year's exam, and we are making this more complicated, should be much more difficult. Hopefully, you will get to know it. So these things will be slightly different than what we have learned before. Well, I would argue that what we have learned so far are mainly operations using certain tools in Excel. But this lecture will involve more logical thinking, mathematical expressions, and dealing with spreadsheet formulas. Specifically, we are going to learn this case study. Later, we will go through this in details. That is a much more complicated version of the previous year's last question of the previous year's final exam. So its original version was already the most difficult, but we are making it more complicated. So again, don't panic, please. And then we will talk about the base case analysis, which is all the necessary computations to help us build the model. And after that, we may not have all the time to complete everything. We will talk about different what-if analysis, including data table, goal-seek, and solver optimization. I understand many of you are also learning using solver for linear programming, LP. But the reason I'm saying this case is complicated because in the end you will realize the problem is not even linear. So using LP is not, we cannot even using a linear solver. So it will be non-linear. Before we start, during the break, I realized certain things. Naturally, I will reply all of your emails if you send it to me. But sometimes I realize some of your emails have never reached my mailbox. So if you send an email to me after maybe 1 or 2 days, maybe 2 days, you haven't heard me back or haven't heard any reply, I encourage you to resend using the university email. Because if you're using a personal email, in many cases, it will either go to the junk box or even I cannot find some of it in the junk box. So, right. If you use the university email address, I'm sure that I can get it. So if you send me an email, I never reply. I mean, it's probably because I never saw it. So just a quick message. And if some of you want the course previous recordings, you can also send me an email by individually request. The reason I'm not automatically posting all the previous recording available is that in that way I would expect less of you to come to the offline lab session, right? You can just watch the recordings, never come to the class, which is, of course, less efficient. So, okay, let's briefly talk about this case study, where let's go through the story first, and we will go through the so-called exam question, which is, again, let you know that this is a complicated version of the exam question. And before we go to the details, I will, on a very high level, try to teach you, whenever you are dealing with a problem like this, how do you approach it in general? And then we are trying to, piece by piece, in the very detailed step, build the model together. So the background or the story of this case study, imagine ourselves to be a sales manager in a global company, and we are producing and selling a product in 3 different markets. North America, we can call it NA. Europe, we can call it EU, and Asia. So we have 3 different markets, and they are parallel. So whatever the quantity we are computing, potentially we may need to compute for 3 different markets. And we need to make a one-time production plan for all the 3 markets over the entire year horizon, which is over 12 months. The objective is to maximize the total profit across all 3 different markets across the year. So in the other PDF called production planning, right? I still leave the title to give you idea. This was the final year, the final exam in the previous year. We have the most detailed description, including what is the business context, what are all the relevant inputs, and also to facilitate. If you want to think on your own, you can ignore the hints. But if you need certain help, extra help, here I give you all the hints of certain quantities. If you do not know how to compute them, here is some quick expressions or formulas. But let's take a look at those later. So we are producing and selling a product in 3 different markets, and our decision variable would be a one-time production quantity for all the 3 markets. Let's take a quick look at all the inputs we have and think about how potentially they can be useful in our analysis. So we have the selling prices in the 3 individual markets, 30, 32, and so on. We have the unit production cost. So naturally, the selling price is higher than the unit production cost, which means that for every unit we sell, we will make a profit or a revenue, right? So we have a fixed monthly cost, 5,000, 7,000, 6,000. Monthly cost means that we need to multiply this number by 12 for a year. So these are the fixed costs. We need to pay for that no matter what. So then things will get a little bit trickier. We are going to talk about the demand. Demand naturally means, so before we talk about demand, I assume many of you should already learn or at least heard of, news vendor problem. This setting or this business context is similar to a news vendor setting, but easier because everything, the demand will be deterministic. There's no uncertainty. There's no random demand. So let's see, how do we assume the demand quantities? In the first month, which means in January, the demand are 1,800 and 600 for the 3 markets. Each month after the first month means that February, March, and so on, the demand will have a growth rate. For example, if the first month demand for NA is 1,000, the second month demand for NA will be 1,000 multiplied by 1.05, 5 more percent. And each month is like accumulating the interest or something, right? Compounding. 5% increase growth rate for each month after the first month. Then about the production quantity, which is supposed to be our decision variable, we need to decide a production quantity for all the 3 different markets at the beginning of the year. For the base case, we assume they are constants. We assume our production quantity for the 3 markets are 20,000, 20,000, 20,000. Same for all 3 markets. Right, those are the basic information. Do not get overwhelmed. I mean, this is a lot of different types of input. Later, we will try to, on a high level, try to categorize them and understand so that we do not forget about anything. So the last piece of information for all the markets, at the end of each month, we will have an inventory holding cost of 0.2 per unit. So this is the holding cost. And in a typical news vendor setting, we will also assume underage cost or recycle value. Here, we do not assume anything, so 0 for those unmentioned quantities. We have some extra information just to clarify things. Inventory, of course, it cannot be negative. Once you sell all the things on your hand, you cannot sell anything, right? Any unfulfilled demand will be lost. So if we deplete all of our inventories in a certain market, the remaining, the future demand, we cannot satisfy any of those. And the last point, for simplicity, we will allow fractional units. So there's no integrality constraint. In other words, we do not explicitly require that the products units are integers. We allow something like 0.5, 1.7 units of products. So these are all the inputs. So before going into building the model, I will first give you a very high-level idea of any question like this. How should we approach? So these are some things that personally, whenever approaching to a new business spreadsheet modeling or mathematical modeling model, several components or several factors I think of. So let's try to explain one by one. So first, we need to understand what is the objective. And more specifically, how the objective can be potentially decomposed or computed. Back to this example, the production planning example, clearly I already tell you that our objective is to maximize the total profit for all 3 markets, for all 12 months, right? So you should start thinking of, how do we decompose the total profit? In other words, you should think of, not explicitly, may not be, but how do you write down an expression of the total profit? Later, I will show you another slide. For example, we already talked about several components, right? Sales revenue, production cost, monthly fixed cost, inventory holding cost. Those are the essential components that we will compute one by one. And in the end, we will sum all of them together to compute for a final single value of total profit. So we should have overall structure of how do we construct our objective and their individual components. Also importantly, we need to think about what is the decision variable. In the base case, this is less important, but in your real life and in your real work examples, this will be one of the most important things. You need to think of as a decision maker. Here it's you are a sales analyst. In other cases, you may be a data analyst. As an expert, you need to think about what can be your decision. In other words, potentially, which input can you change? Because this is important because as a decision maker, if you cannot change any input, if none of the input can serve as your decision, there's no point in modeling the whole thing because you cannot change the system at all. The reason that we say that mathematical modeling or spreadsheet modeling, or more generally speaking, what we do in the DAO apartment is very important, simply because we can utilize models to make better decisions. So I will never tell you that once we finish building the model, that's the end. Okay, we're done. Let me make an incorporate analogy. It is as if you are having a gold hen, a chicken, but you just leave it there. Our objective is to have golden eggs, as many as possible, right? So building a model is like having a hen. We want to have golden eggs, which is, to make better decisions by doing what-if analysis, by doing optimization. So decision variable is very important. Also, we need to analyze intuitively what will be the key trade-off. If you think about changing the decision variable in different inputs, usually for any optimization problem, there's no clear optimal solution as the extreme value. For example, here, think about our example. The decision variable is the production quantity. Very classic trade-off in this kind of news vendor or supply chain related examples. When we need to decide on the production quantity, typically speaking, the most common trade-off is between producing too many and producing too few. In this case, particularly, if we produce too many, we will have a lot of inventories on our hand by the end of each month. So we will incur a large inventory holding cost. If we produce too few, we will not be able to satisfy all the demand. So there will be certain opportunity costs. Right? There are certain demand out there that we do not capture. So we make less revenue or less profit. So that is the key trade-off if we talk about production quantity. Always think about the key trade-offs in any of the decision-making problem. For example, when I personally do research, I do price optimization, revenue management. So if we are trying to optimize price, the key trade-off is that, okay, that is also classic and typical. If you set price too high, fewer people will buy your product, then your revenue would be low. If you set your price too low, many people will buy it, but since your price is too low, your revenue is still low. So typically speaking, for most optimization problems, there is a sweet spot in the middle so that your trade-off is balanced. That we say it's optimal by maximizing or minimizing your objective. Here, our objective is to maximize, is considering the profit. So we are maximizing the total profit. And after you think this clear about the objective, the decision variable, the key trade-off, then we can start thinking about the details in terms of the expressions of calculating the terms. Right. On a very high level, for any mathematical modeling related to optimization, these are the things you should think of. Of course, if you're learning LP, I will also encourage you to think about all the constraints. But in this case study, we do not have any constraints, so I will leave it there. So let's talk about this one by one, starting by the objective. As we say, in your thinking process, the first step is to think about what you are trying to maximizing or minimizing, what you are trying to optimize. Here, we are trying to maximize the total profit and their individual components we already talked about. We need to think from the top to the bottom. The top is, of course, the total profit. Then one level below are the individual components, including fixed cost, production cost, inventory holding cost, sales revenue. And then to the one level below, we need to think about, for each individual component, how do we compute them? Which are the related quantities that we need to keep track? One of the challenges in this exercise is that we have 12 different months. So we need to keep track certain quantities like the demand or the sales or the inventory for consecutive of 12 different months. So here I help you better understand for each individual quantity to compute the total profit, I list down what are the potential lower level quantities that we need to know in order to compute the corresponding cost and revenues and so on. For example, the production cost will depend on the production quantity. That is our decision variable, which we assume to be fixed. The inventory holding cost will depend on the inventory level by the end of each month. So we need to keep track on the inventory. And for the sales revenue, this is the most typical and classic expression in news vendor or in supply chain. For those of you who are unfamiliar with news vendor setting, totally fine. Let me try to convince you that the way that we determine sales quantity is by comparing two values. One is the realized demand, or in other words, one is the demand, which means how many people are there in the market that want our product. The other quantity is how many units of products you have on your hand. Depending on which value is lower, we can sell at most them. More specifically speaking, the sales quantity, depending on two scenarios, if your inventory is higher than the demand, you can only sell up to the demand because no other people will want our product. So we sell the demand. When demand is lower. In the other scenario, if the demand is higher than our inventory, we can sell at most the inventory because we cannot satisfy the excessive amount of demand. We only have certain units on our hand as inventory. So I list down all the expressions, all the formulas in the original description, but we do not need to overly rely on those. We can think of them logically in our own heads. And sometimes it can be helpful to draw simple timelines if your model involves multiple time periods. Let me try to simply draw it to help you better understand certain things. But please bear with me, my drawings using mouses on the screen can be very bad. So for the timeline, again, just to help you better understand, I'm not making any promise on my drawing skills. No. So we have a total of 12 months. Let's say 1 month number 2, all the way to month number 12, December. For each month, if you think in the most detailed structure, which are the quantities that we need to keep track or we need to compute? So for each month, I would say, first, we have the demand. We can use D, right? So in the first month, we will have D1, which is the demand for the first month. Then, depending on in the first month, depending on our inventory on our hand, which is I, we will compare the value between D and demand and inventory to determine our first month sales, which we can call it S1. After selling the S1 amount of sales, at the end of the first month, we will have the end of month inventory. Here, to start month inventory, we can call it I0. The end of month inventory, we can call it I1. This I1 will be useful to compute the inventory holding cost because the inventory holding cost, we will multiply the end of month inventory by a constant unit holding cost of 0.2. And we will repeat for the remaining months. For example, for month 2, we will again compute the demand in month 2, D2. Then inventory for month 2, which is month 1's end of month inventory, which is I1. And we compare the two values to determine the S2, sales 2. I'm running out of space. And we sell S2, so subtract S2 to get the end of month 2 end of month inventory. So this is roughly the sequence of events happening in our exercise. If you do not get all the details here, it's okay. We will do it over again in the Excel spreadsheet. Again, apologies for my bad drawing, so it's a bit harder to understand. So let me remove all of this. Just to give you a illustrative idea, but we will do a better job in the spreadsheet. So far I'm all talking about brain exercises or what you might be thinking in your head before you start working on the exercise. So the first step, once you decided, okay, now I have more or less a pretty good understanding of the whole problem, I'm going to start working in Excel to construct my model from scratch. So my suggestion, or I strongly encourage to design the layout of your spreadsheet in certain ways so that you put all your parameters into a designated area. This is what we call modular input. So all the parameters So you check, you go back to the Excel file. Sorry, you go back to the PDF file of descriptions to put all the numerical values based on their categories into a smaller table in the spreadsheet. And then you understanding each of them, and you put all the other quantities like our decision variable, our final input to be computed, as well as the decomposed version. And once we start from there, it will be modular, more structured, and it's easier to guide you. How do you compute individual smaller components based on the inputs? So let's open the workbook called Production Planning and try to build a model together. Let me put the PDF on the side. In case that you do not follow certain steps, I'm including all the formulas as well as the final answers in the third spreadsheet. So this is the completed version. But we will do the whole exercise from scratch in the second spreadsheet. So to start with, in the first spreadsheet, I give you a so-called bad version, which is a bad example. This is the version when I was working on the solution on my own in the previous year's final exam. I worked for like 10 minutes on this example, and I give this to our TA that potentially it would be useful for grading. But this is, I wouldn't say it's wrong, because for the final number, we get the same number as what we get here. So the answer itself is correct. But later, once we finish our good exercise, we will make a quick comparison. And I will argue in certain different perspective that this practice is just not good, not good. So let's forget about the first spreadsheet for a moment. Here I also put the question, right? There are certain things that we do not like about this way of working on a spreadsheet modeling. So we will use this instead. And this is the recommended way, and also it will make our life much easier, it turns out to be. So I have already done the first part for you, which is to summarize all the inputs in the parameter table, which include, again, let's quickly go through the selling price, unit production cost, fixed monthly cost, the demand in the first month, the demand growth rate, and the inventory holding cost per unit per month. Those are all the inputs, all the numerical numbers we have in the PDF description, right? Later we will see. You may think, okay, I don't bother why we should spend a few extra minutes to fill in this table. Later we will show, right? This turns out to be very convenient because whatever input, if you want to change it, you only need to change the numbers within this table without the need of changing any later detailed calculations. We will show that after we complete the exercise. Then I put the decision variable in a separate area just to show that, okay, this is also part of the input, but potentially in the what-if analysis or in the optimization, we can change. This is something that we can decide. But for the base case, we will assume that they are fixed numbers, like 20,000 for each. Also, to make our life easier, our only goal, our only objective in the base case analysis is to build a spreadsheet model to compute our total profit, which highlighted in the signal cell. But in order to do that, we already do the thinking process in our brain, in our heads, right? The profit will consist of 4 different components: the holding cost, the fixed cost, production cost, and the sales revenue. So our intermediate goal is to fill in this table of the 3 different markets, holding cost, the 3 different types of cost, and the sales revenue. Once we fill in this table, we can use the sales revenue to subtract all the costs to get our final profit. So this is like a backward induction. So we need, in order to get the total profit, this is what we need. And in order to get this cost and revenue, we need to keep track of the following quantities, which includes demand, sales, end of month inventory, and holding cost. In this very complicated example, I already give you multiple things to start with, which includes the input parameters, which include how do we decompose the objective, also include the quantities that we need to keep track. Potentially in your homework or in your final exam, this will be done by you. So that, I would argue, is one of the most challenging parts. But of course, it will be correspondingly much easier than this one. So let's start our computation. Under calculation area, we need to make sure that all the reference are back to the original. If necessary, all the reference, we do not simply put in constants, but make a reference to the parameter. So if any parameters are getting updated, we do not need to manually change anything in the calculations. It will be updated automatically. So let's get started. The first thing that we are trying to calculate is the demand. In other words, for the 3 different markets and for each individual month, what are the demands? The demands in January or in month 1 is straightforward, right? Because I already gave it to you. Demand, month 1 demand. So we make a direct reference. Instead of putting 1,000 here, that's not good, that's not encouraged. We should make a reference to the original parameter input. You may ask, why is that? Why bother doing the actual reference? For the same reason I just mentioned, right? Later, if you want to update, instead of 1,000, you want to change it to like 2,000. You want all the calculations to be automatically updated itself by making this reference, right? And because this is only for the first month, well, we can simply drag it to fill in the other two markets. So this is the first month's demand by referring to the first month's demand in the fixed input parameter range. So this step should be good enough. Starting from the second month, it's slightly trickier, but still should be easy. The second month's demand will be the previous month's demand multiplied by 1 plus the growth rate. If the growth rate is 5%, we will plus 5%. And this 5%, if you think about this, we should fix the 5% to that market only. In other words, we should fix the row, not the column. You can try it out. You can try fixing the rows or the columns or both. Here, I would argue we should only fix the row. Because, why? Because potentially we do not want to manually input the expressions for months 3, 4, 5, all the way to 12. We want to copy paste and drag in the formula. When dragging the formula across different columns, we do not want to fix the column because different columns represent different markets, and different markets have their own growth rates. But when dragging across rows, we want to keep the same row as row number 10 to represent the same growth rate. Well, you can try it out. You can try not using any dollar sign first, then dragging, then you will realize certain issues, and then you know what to fix. So because we're only fixing the rows, not columns, when dragging across the columns, they will be using their own market's growth rate, right? And for the same reason, because we're only fixing the rows, not columns, when we are dragging down, it will be using the same row or different column. For example, for EU, month number 7, it's still using month number 6 demand multiplied by 1 plus the growth rate, which is 3% in EU. So this is how do we calculate demand. Questions? Maybe I'm going a little bit fast. I mean, this is just one way of doing it. If you feel like, okay, using a single dollar sign, fixing rows, not fixing columns, so tricky, I do not like it. Alternatively, you can also use another approach, which we teach before, right? If you feel like dollar sign is so annoying, alternative way, you can name corresponding cells. Instead of C10, which potentially you need to fix, right? You need to fix certain rows or columns. You can give it a name. Let's say, instead of C10, you can give it to rate 1, enter, rate 2, and rate 3. And instead of referring to C10, you can just referring to rate 1, rate 2, rate 3. But in that case, you can drag across rows but not columns because it's rate 1 to 3. There are 3 different rates. That's an alternative approach, but maybe it will. You need to define the names on your own, right? So we're not going to explicitly doing that. So by doing this, we compute the demand. And then we are trying to compute the sales and the inventory for the first month. If you think about it, again, the one of the major challenge, if you think about supply chain exercise or news vendor exercise, is the difference between demand and sales. Demand is on the market, potentially how many customers, how many units the customer wants. Sales are the actual number of units that you can sell. So sales should be, like we say in the expression, if you are confused or you do not fully understand about certain expressions in the original like exam question description, I give you all the formulas to compute. But for the benefit of our understanding, we should, without looking at the hints of expressions, we should try to understand the logic on our own, right? Here I argue sales for month 1. So how many units we can sell in the first month? It should be the minimum between the production quantity and the demand. So here, by default, we are producing 20,000 units. So it's much larger than the first month demand. But what if, because these are decision variables, the production quantity, if we decide to produce a very small amount, less than the demand, then we may not be able to satisfy all the demand even in the first month. So as a result, the first month sales should be the minimum. We use the function min, M-I-N, minimum, between the first month's demand and the first month inventory at the beginning of month 1. Or you can think of the end of month inventory at month 0. So even before we start the year, how many inventory do we have on our hand? That will be the production quantity, right? So it's between those two values. So by the way, this minimum function is not a linear function. So this is the function, this is the expression why in the end, our optimization problem is nonlinear. And because in this case, our production quantity is very high, our sales is just the demand. Otherwise, if the production quantity or the inventory is very low, we can only sell up to the inventory. So this is our first month's sales. Right? Any questions? You have any doubts? Why do we compute using a minimum function? This is the probably conceptually the most challenging part, especially for those of you who is your first time learning something like a Newsmeter type of question. You can at most sell either the demand quantity or the inventory quantity. In this case, inventory quantity at the beginning of month 1 is just the production quantity. So after knowing how many units of sales happens in first 1, we can compute what is the inventory level by the end of month 1. Well, that would be simple. That will be the production quantity, which is the beginning of January, subtract our sales. Right? We can copy paste and drag to fill in the remaining 2 markets. This first month calculation, again, it will use the so-called previous month inventory, which we already in month 1, so the previous month inventory will be just the starting inventory, which is the production cost. So the production quantity. The production quantity minus the first week sales, how many units we are selling, will be the end of month 1, end of month inventory. So this is our computation for the first month. For the second month, things will be slightly different, and we will complete the second month expression and generalize to all the remaining months. But once you understand why we are using those expressions in the first month, the second month should be more or less similar. For example, what will happen to the second month sales? It is the same. It would be the minimum value. How many units we can sell our products in the second month, in February? It will be the minimum value between our second month demand and our second month starting inventory. What is the second month starting inventory? Well, that's just the first month ending inventory, end of month, first month inventory, right? So it's the smaller amount between those 2 quantities. So you may be a little bit confused. Why are we using the end of month inventory as a quantity to calculate, not starting of the month? Later we will see we need the end of month inventory to compute the holding cost. So let me repeat, because once you understand this, the remaining R should be all straightforward. The sales in any other month should be equal to whichever is smaller between the demand of that month and the starting inventory of that month, which is the end inventory of the previous month. That's why we're referring to January's end of month inventory. And it's the same for all the 3 markets. Not only is the same for all the 3 markets, it's the same for all the remaining months. So we can just directly fill in all the remaining months. And we can double check for a different month and a different area. For example, for August in Asia, let's try comparing. We have not filled in the inventory yet, so the number might not be correct. But let's see if the sales reference are correct. So the sales in Asia in August will be equal to whichever smaller demand in Asia in August, or the demand or the end of month inventory in Asia in the previous month, which is July. So right now the values may be wrong because we haven't filled in the inventory. So let's quickly compute the inventory values. How do we compute the second month inventory? Well, the logic are exactly the same. The second February, which is month 2, end of month inventory, will be month 1's end of month inventory, subtract how many units we sell in the second month, right? So it will be equal to the previous month inventory minus the sales. And it is all the same to other markets and to other months. And you can double check if you want to be extra cautious, you can double check for any market, any month. The end of month inventory should be the previous month end of month inventory minus the current month sales. So we are more or less done. For the calculations, we're more or less done. If you are sharp, if you are quick, you already realize there are certain things, right? If you keep track of the end of month inventory from month 1 to month 12, you realize by the end of month 12, which is the end of the year, you still have a large positive amount of inventories, which means that our initial decision of production quantity must not be optimal because we are not depleting our inventory. And by the end of each month, we will incur certain holding cost. You can pretty much imagine what the optimal solution will look like. In the optimal solution, by the end of month 12, we should have an inventory of 0 because there's no recycling value, right? We should deplete all our inventories to satisfy all the demand. So that is the extra thinking if you are following quickly. If you don't get it, that's also fine. We will gradually realize how it is. So this is the calculation. Just to double check to help you better understand how they interact with each other. Now our decision variable is fixed, so we assume that all the 3 markets will have 20,000 production quantity. We can quickly do a sanity check. If you change the production quantity to any of the market to 0, if we've done all the expressions correctly, the sales should be all 0 and the inventory should be all 0, right? Because we produce nothing for that region. So all the demand we cannot satisfy. So the sales, we cannot sell anything because we never produce anything. And so the inventory will also be nothing. Let's quickly check. Let's say if we change NA, we completely abandon that market by changing the production quantity to be 0. And this is what we want. For the NA market, all the sales are 0 because we cannot sell anything. We have no inventories. And of course, there are no holding costs. Later we'll compute holding costs. But the trade-off is that, well, we do not have holding costs. We also do not have any revenue. So let me change it back. And the only remaining thing that we need to compute is the holding cost, which is trivial. Because by the end of each month, we just multiply the inventory level by the constant unit holding cost, which is 0.2. So again, we do not want to directly write down something like this multiplied by 0.2, which is not good. Not good. As the standard practice, instead of writing down the constant, you may already realize why this is not preferable. Because if you write 0.2 here, later I tell you, oh good, inventory holding cost we just reduced from 0.2 to 0.1, then you need to manually change all the constant of 0.2. But instead, we are going to make a reference. This is the standard way to do it. Make a reference to 0.2, fix it because it's always that single constant. So later, whenever we want to change part of the input, we can manually do that by only changing the single cell. All the formulas will be correct still, and they will be automatically updated. All the remaining markets, all the remaining months, they're the same. So we have completed all the detailed computations for this exercise. The only remaining task is to aggregate by month and by category so that we can compute the final total profit. So let's compute the 4 individual components of the objective. So first is the holding cost. Well, of course, the holding cost for a specific market will just be the total holding cost for that column, right? So across all the months. We use a sum function. So that's the holding cost, and we can copy paste the formula to other markets. Next one is the fixed cost. Well, fixed cost is even simpler because it's just the monthly fixed cost multiplied by 12. We need to pay this amount for each month, right? 12 times a year. Will be equal to this number multiplied by 12. You may choose to fix this cell, but we only use it once here, so you do not need to fix the rows. Columns, we do not need to fix it because we are going to copy paste into other columns. So this is the fixed cost. And then we have the production cost, which is by definition the production quantity multiplied by the unit production cost. Right? And lastly, we will have the only positive term, which is our sales revenue. And hopefully it will cover all the costs we have so far. So the sales revenue would be the summation of the sales across all months for that market, multiplied by the selling price, which is also a fixed input from the table. So hopefully the computation of these several terms should be intuitive because it's an aggregate level calculation. And our final step is to combine all the numbers here to compute the total profit. Well, the first three terms are cost, so we need to subtract the first three from the last row. So it should be equal to the summation of all the revenue, subtract the summation of all the costs. And that's the end of the base case analysis. You can double check if you have the same number as the output. If not, you can quickly compare with the third spreadsheet, which contains all the formulas, all the correct expressions, and so on. For easier checking, let me teach you another short key. On any of the spreadsheets, you can click Control plus the back quote, which is tilde, which is also the key on your keyboard, the key next to on the left side of the number 1 key, to show all the formulas. Control back quote. So it will show all the detailed formulas for you to check, right? Whether it's consistent than what you expect. Control back quote. The key is on the top left corner of your keyboard, below EXC, left to number 1. Alternatively, if you do not like this short key, you can go to formulas. I think there's a show formula. Yes, this little icon means show formula, which is control. Here it shows, right? Control back quote. Might be useful in certain cases. So any of you encountering any difficulties in computing certain terms or using any expressions, if you have successfully get this final number equivalent to this number, around 108 or 109,000, we are good. We are good. Let me pause here briefly to see if I need to address any individual questions. If you have any questions, raise your hand now so that I can help. If no, let's go back to quickly compare our the standard version of making the spreadsheet modeling exercise against my previous year's exercise of this bad case and compare where we do not like the bad case. So there are several things. First, and probably the most important thing, I do not make a designated or committed area for all the value inputs. For example, here, if we talk about the monthly growth rate, I simply put in all the formulas for computing the inventory, like 5%, appearing all the cells. This may save me several minutes when building this spreadsheet. But in the future, once I have a potential different input, instead of a 5% growth rate in NA, suppose I have 10%, my life will be miserable because I would need to manually change all the 1.05 to 1.1. So this is one good thing about make a modular spreadsheet, so that all our parameters, all our fixed input belong to the same area in the same table. So that for whatever change of input we have, we only need to change the constants appearing in the table without having any need to worry about the computations appearing later, because we know the formulas will still be correct with different inputs. So this is the first thing that we do not like about this first spreadsheet, the bad exercise. Another more important issue is that some of the formulas I use here are simply wrong. They are not correct. They are not even correct. Because if you pay attention, when keep track of the demand or the sales or whatever the inventory, I never use the minimum function. This is because I was quite confident that our initial production quantity will be enough to cover all the demand. So we never run out of the inventory. But again, if we change the production quantity to a smaller value, that in some cases, in some markets, we may not be able to satisfy all the demand, then this calculation may even be incorrect. That's the second thing that is just wrong. And for the third reason I do not like about it, some of the formulas are too long. Again, because I was quite familiar with the whole exercise, and last year I was trying to finish as soon as possible to give it to TH to just compute the final number, then this would be okay. But imagine if you want to make a spreadsheet modeling for yourself in the future, for your colleagues, or even for your boss, for our bosses. Then if you give him to her something like this, and just tell him or her, you find out what does each expression mean on your own, by yourself. Well, that's not very good. Instead, I'm not asking you to carefully design the color code or the modular, because that's maybe sometimes it's too much. Maybe during the exam you will not have all the time to do this. But still, even for your own, try to make less mistakes. I encourage you to make the detailed calculations as low level, as detailed as possible, so that for any formula, it's relatively easy. You do not need to make several calculations combined into a single cell, like what I did here, right? Like something like this. Here I only have demand and inventory, but some intermediate steps, like we need to compute the sales, we need to compute holding cost. Well, I'm not saying that calculations here for the inventory is incorrect, but for easier understanding or easier presentation, maybe you should separate another table to compute the holding cost separately, just to make it more clearer. Right. So when you review for your homework or for your final exam, do not treat this spreadsheet model like the standard one. This is the bad example. So we should not learn from this. Instead, do something similar to this. Right. So if you are curious, or if you wonder certain formulas, why do we have that? In the slides, I also quickly summarize the expressions or the calculations for certain quantities, including the demand, which was the previous demand plus the growth rate, the sales, which is the minimum between two quantities, the inventory, which is the previous inventory minus the sales, and finally the holding cost, which is just the inventory multiplied by the unit holding cost. So in this slide, I'm trying to give you a quick summary of, back to the high level, some not strict requirements, but recommendations when you work on spreadsheet modeling, mathematical modeling like this. So a good practice is to sketch the spreadsheet first. For example, reserve an area for all the parameter inputs. And similarly, organize into modules like parameter region, decision variable region, objective region, and detailed calculation region in the bottom. There are several benefits. As we already seen. Right? Keep it simple in a way that we avoid long formulas. If you have specific cells that your formula is too long, consider decomposing them into smaller, more granular quantities to compute one by one. So it's easy to debug and to double check. And of course, design for communication. Well, in your future work, you may consider design the workbook so that it will be readily and easily to use by your other colleagues or bosses. But I understand it's not a must-do. It's not a compulsory requirement, because in your final exam you will have limited time to construct the spreadsheet. So there's no explicit requirement on this. And if you have time, of course, you should document important data and formulas like what I did in the slides. So we have less than 10 minutes. I will quickly talk about the what-if analysis. But before that, I want to let you know that if you still recall my previous analogy on the golden chicken, golden hen, and the golden eggs, right? Now that we already complete constructing the model, we haven't put it to use. Otherwise, we only build a model, but we have not used the model for any decision-making process. So that's a waste of resource. So to put it in the most use, we will consider multiple different use cases of what-if analysis. And we will start by the simplest possible what-if analysis, which is, this is so simple that I do not even include it in the previous year's exam. So the most straightforward what-if analysis, from the name you already know, what will happen to the objective if we change certain input? So here I ask the quick question. Now the inventory holding cost is 0.2 per unit per month. What will happen if instead of 0.2, I use 0.1? Now if we go back to the first bad example, we immediately realize, okay, this is bad because it's not easy for me to conduct. I need to manually change all the 0.2 to corresponding 0.1. So not very convenient. But back to our standard case, it's just by a simple change of input parameter. And because all our computations are using formulas and references, if we done everything correctly, our profit or our objective should be automatically updated to a different value. And of course, because our holding cost become lower, our profit will become higher. This is the most fundamental and the simplest what-if analysis. But of course, we can do potentially much more. So in the previous year's exam, if you have successfully done the first question correct, you've earned yourself 8 points. But I mean, this example is much, much more complicated than the previous year's, so 8 points is. Also, when grading the previous year's exam, a much simpler version than this, our TA, I've told our TA several times to be as lenient as possible. As long as you build the overall framework, even if you make several mistakes, you will still get the majority of the points. But that is only for the first part, question A. For question B, C, and D, we are doing what-if analysis. So let's take a closer look at question B, right? Which is 4 points. So we already have a basic model. We will start from the basic model and use data table to answer the following question. Again, it is like the what-if type of question. What if we are changing different values for the selling price in NA from $25 to $35? $1 per increment means that 25, 26, 27, all the way to 35. And at the same time, we are also changing the unit production cost for NA from $5 to $15, 5, 6, all the way to 15. So if you think about this, this is a more complicated what-if analysis because we are changing two variables at the same time. And for any combination of all the possible values, I want to know what is the total profit. Specifically, we are going to change the selling price for NA by varying the possible value 11 times, 25 to 35, right? 11 different values. And also the production cost for 11 different values. So 11 multiplied by 11, we have more than 100 different scenarios. You can do this manually, but of course, this is not applicable or not even possible. What do we mean by manually? If we want to know certain combinations like 25 selling price, 5 production cost, what you can do is to manually change, let's say 25 and 5, and naturally you will get an output. But what we need right now is to enumerate all the combinations of 25, 26, all the way to 35. Then for this input, 5, 6, all the way to 15. So more than 100 combinations. We want to know all of their inputs, all of their outputs for the total profit. So this is not a single what-if analysis, not a single scenario, but multiple scenarios in 2 dimensions. So we will need the help of Excel tool called data table. So to use data table, actually we have a separate workbook. Let me save this. Separate workbook called sensitivity analysis, which will explain to you all the detailed steps to do two-way or one-way Excel tables. So there are 4 steps, and we will quickly go through the steps, and we will work on the details maybe next week because we do not have plenty of time. So the first step is the most straightforward. The first step is basically copy-paste or start with the basic model, which there's nothing new need to be done by us. So in other words, in order to do a what-if analysis, you will first need the basic model to work, to make sure all the reference, all the expressions are correctly done. So this is, of course, very important. Then the second step is to make a table. Depending on how many variables you are going to change at the same time, if it's only a single variable, that will be a one-way data table. If it's 2 variables at the same time, that will be a two-way data table, right? So here we are using the more complicated two-way data table because we are changing the selling price together with the production cost. So we are going to list down all the possible values of each variable. For example, let me zoom in a little bit. For example, for the selling price, we are varying the selling price in the column or in the row. It doesn't matter. You can switch the rows and columns. We are varying the quantities as required from 25 all the way to 35. And similarly, if one appears in the row, the others will appear in a column. So the production cost, we will vary all the possible values from 5 to 15. This is the second step to build the structure of your data table. The third step is also easy, is to make the reference. If you have a two-way data table, on the top left corner, that empty cell, you are going to make a reference to our output cell. So this cell, our output cell is C19. So you will make a reference to C19. let me explain a little bit why we are doing this. So later, our last step using the data table, which we'll probably do next week, is to select all the area. And by applying a data table, essentially the mechanism is that later we are going to refer those potential different values to their original places. For example, production cost, $5, we're going to refer to the production cost here. Now it's 12. And for the $25, we'll refer to this selling price of 30. What Excel data table will do is that it will automatically and manually change all the corresponding cells, they are called row and column input cells, to the new value. Instead of the basic model values like $12 and $30, it will, for each combination like 5.25 or 15.35, it will replace the default value with the new value, and it will recompute our objective. How does Excel data table, or how does Excel know that this value is the value that we want to compute? Simple, because we make this reference. By making this reference of the output cell on the top on the top left corner, Excel table will know that, okay, this is the cell of formulas that we're interested in. So in the last step, which we'll show you later in next week, after applying the data table for all the possible combinations of different inputs, we will get potentially different total profit as output. And by doing that, we get all the more than 100 combinations of different what-if analysis as different inputs. But we are now slightly already over time. Let's stop here, and we will continue next time. And other than data table, we will have one-way data table. We will have GoSeek, which is simpler. And we will briefly talk about solver optimization, which should be straightforward. If you have any questions, talk to me either now or send me an email. I will see you next week.